Thank you.
So I'll run on to a project I'm working on at the moment. So this is the one I mentioned before with Ben Hicks at Bristol and at Bath. So we've got about 10 lecturers and professors of varying levels, 4 postdocs. Come into 4 postdocs. We've got 2 or 3 PhDs starting in the next year as well. So we'll end up with a team of probably 15 or 20 people supported on this one between full-time and sort of 0.25 commitment, something like that. But the premise of this one is based around monitoring and managing large-scale, complex engineering projects. So this slide always starts my presentations, but I don't think any of you really need to see it. So all of this says is engineering projects are big and engineering projects are complicated, and all of that gives us issues that we have to deal with. So the standard sorts of facts, $3 trillion in the total value of large global engineering projects. I think we've got a stat somewhere that in the time it took to make the average presentation, the US government loses $150 million on engineering projects through delays and various costs as they go through. So there's not really much doubt that something should be happening in order to try to support these, which I think a lot of us are trying to work on at the moment. But this project, I think, can be traced back a little bit to this quote by Jeremy Watson, who's at Arup in the UK. So they do, you probably all know Arup, I suppose. But this was something he said during a talk at the University of Bath during one of our student events, actually. So we get guest speakers every now and then, and they talk to however many hundreds of students. But in any project now, there is a huge amount of data that's generated, not for the sake of generating data to analyze, but just as part of the process. So emails go back and forth between different people, CAD files are made, FEA files are made, spreadsheets are made, reports are filed and never looked at again, presentations are given to different groups at different stage gates, budgets, whatever else you can think of. And in the creation and content of all of those is a staggering amount of information that we don't have the capability or the motivation to try to capture at the moment. Probably more capability and less motivation. And so our project is based around trying to work out what we can do to capture that and how we can capture that if we can, and what elements and what aspects, hopefully for the purposes of trying to manage and monitor projects and really trying to aid project managers and engineers in their processes. So we're not trying to, at the moment at least, provide the information that says you should do this, you should do that, you should do whatever in your project. We're trying to provide the means for people to say we're looking at our project, we're trying to spot patterns, we're trying to understand what's actually happening, and then people in the appropriate context can make the decisions of what should be done based on that information. I think that's a very important thing we're trying to aim at. We're not trying to say you should do this because we have no idea what they should do because we don't work in their company. We're just the academics on the outside, and what we should be doing is providing them with the means to make their own decisions, but in a much more informed way. And at the moment, because so much information is lost, they've got almost no real-time means, especially, of saying what's happening in their projects. And everything is based on their experience, which is very valuable, their training, going back however many years. But those can only go so far when you're trying to deal with certain situations that have never arisen before, and when you can't actually see what's actually happening in your project. And as a result, things always happen in the same way as it's always happened before, when perhaps things could be done differently for a much greater effect. At the moment, just don't know. It's all unknowns. So that's what we're trying to lean towards, is provide the means for people to try to work out what these unknown unknowns might be, and what information could feed into them. And so this is the proposition, I think, that was at the top of the proposal a few years ago, submitted to the EPSRC. So is it possible to generate understanding, insight, and predictions? Predictions is the big word there that we might achieve in a few years' time. Looking at current and future status of engineering projects through understanding of changing content and structure of digital objects and electronic communications. So really that's understanding what's actually happening at the moment in real time, which does mean we need to do automatic analysis as much as possible as well, and looking at the internal parts of a project as defined by the things that people actually make through it. So rather than what people actually say, but what they actually do, and using that to create a reflection. So into the way we're going into this, I've mentioned already hundreds of emails and that sort of thing to look at. So we're looking at what we call digital objects, which is an incredibly broadly defined set of words that we just say means any digital file that's got, you can define a boundary for. So a communication object can be an email and all of its attachments. Representation objects can be CAD files or FEA files or anything that represents the product as you're trying to make it. Records we have as any reports or presentations, which we have separate to communications, because often the reports and presentations aren't there to transfer information, they're there to save information for posterity, which is still a form of communication, but it's a slightly different purpose. And records, as a result, tend to be a better reflection of final product and final state, whereas communications are a better reflection of ongoing process, ongoing progress, and changing content. And so what we're doing through these is our various analysis techniques, as I'll go through, and we're trying to produce various optimizations, early warnings, characterizations, and that sort of thing. And the best way, I think, to understand our approach is as similar to condition monitoring or integrated vehicle health monitoring, which is anyone familiar with either of those? Should I do a rundown? So condition monitoring and IVHM are both fairly recent things in engineering proper as defined fields in themselves, I suppose. This is something that came out of Airbus in 50s, 60s, 70s initially, and it's based around design for reliability and reliability-centered maintenance, RCM as they call it. And it's all trying to, instead of saying you need to replace this every 6 months, is to find ways to actually monitor parts and components and do that in such a way that you can monitor their performance and predict when they're going to fail according to various thresholds. So you can do appropriate and active maintenance and say, well, this has got 3 months left, which means we need to repair it in this method. And that's grown through various companies. NASA in the 90s, I think, did quite a lot of work on it. And it's led to the point where they're now trying to put various instrumentation on individual components, so really low-level stuff. So they're looking at, if you have a shaft, you look for vibration, you look for rotation rates, temperature, and a few other very low-level things, and then take all of that data and infer upwards to say, how's it performing? If it's not performing, why not? What the diagnosis is and what the prognostics are. So you would look at the sensor data and say that the performance of this as non-ideal is most likely to wear in a certain quadrant of a bearing, and the actions you should take on that are to oil it at this frequency for this long before it needs to be replaced by this component. And all of that's an automatic system. So various machine learning at the higher levels and everything based on physical principles and physics at the lower levels to be able to say from this low-level sensor data what's happening at a very high level. And that's exactly what we're trying to do with our project. So we're trying to get very low-level sensor data of engineers and what they're doing on a day-to-day basis. So how many emails they're sending, what those email subjects are, how many CAD files they're making, what their modification rates are, what sub-assemblies they belong to, and then trying to turn that upwards into a high-level understanding of, as you'll see, essentially anything about the project. That would be great if we could have some direction as we go on, by the way, so you can be thinking of what we should actually be doing rather than just everything as we go. But it's that premise. So we're trying to acquire low-level data, do some form of manipulation on it, use that to say this is what your state in the project is, use some form of understanding on that to say whether that's healthy or unhealthy. We quite like the term health because people can latch onto that quite nicely, and they don't immediately assume that if you say something's healthy or unhealthy, you know exactly what the problem is. They just assume that you know that something's good or something's bad and that you can dig into it, which is quite nice in industry when they don't immediately expect you to know the detailed answers and they expect to work it through with you. But then from health assessment, saying whether things are on the plus side or the bad side, it would be nice to be able to say how things are going to go in the future, particularly towards the negative early warning systems, but rather than just saying something's going to go wrong in 2 months, to say that the current trend in this particular part of the project is going to swing downwards, which is going to have this causal effect on these other parts. And as a result, you should be perhaps looking at X, looking at Y, not telling people what to do, but giving them the data that will let them sort of make these pathways and decisions as they go through themselves. Does that make sense? Is there a summary of condition monitoring? So we're trying to take something that's been very, very technical and very, very mechanical for the past sort of 10 years. The field's really been developed, but we think it's very applicable to management and systems design and project management as well. And so we're trying to bridge this gap at the moment and use as many of their tools as we possibly can in their structures to try to produce this management understanding rather than component understanding, I suppose.
Can I ask you,
yeah, of course.
The data, is that from everybody involved in a current in a project, or is it a selection? Or
well, data sets at the moment are the selections that we've been given, but the aim is absolutely everybody.
Okay.
So it's as big data as we possibly can. I think that's probably the only way to really get a decent understanding of everything. Whenever you make a selection, unless you can do a truly random sampling through a company, and if you're going to be doing truly random samplings, I think you've then also got the permission to sort of take stuff from anyone, so you may as well. But whenever you've got a smaller subset, it's going to start skewing particularly to that individual team, which is going to start ignoring other teams as you go through. And also considering that as much of this is automatic as possibly can be, doesn't really matter if we have absolutely everyone. So we just need a bigger computer if it gets too computationally intensive.
So the health term is used as a metaphor for the state of the project. Do you use it even more elaborated than that? Can the project have an infection that will later lead to the death of the patient? Or
it's a very nice way to get our point across quickly to companies, we've found, because we just talk about their project as a person and say your project has diabetes.
Yeah.
And, and you've got these specific issues and these specific parts of the project, and as a whole this is having an aggregated effect in this other part. But the good part of doing this is in symptoms and causes, because people understand symptoms and causes in health, and they don't really understand symptoms and causes in project management or the industry, as we find that it's all the same sort of thing to them. And so another thing we were talking about yesterday is in everything's a communication issue. And so they say, well, that didn't work, it's communication, that didn't work, communication, that didn't work, communication. And often the fact that communication isn't working is true, but that's actually a symptom of a vast underlying network of other problems that are going through. And it might be a communication problem somewhere, but the actual problem will be somewhere else. So we've seen examples where the designers are making something that doesn't quite work for its market and where it needs to be, and that gets fed back to the designers, but via the marketing people and the sales people, who are the first point of call for the customers, and that then gets fed from them back to the designers. And in that transfer, they lose the vital information that they need to know and fixes the product. So what they then have is, well, there's a communication issue, because they're not getting the right information, and say, well, the problem in this project is communication. It's like, well, it's not. The problem in this project is that doesn't work. And if that did work, you wouldn't have a communication issue. The communication issue is actually a symptom of the company hierarchy and the company structure and the pathways of information through. So that's something that they then need to fix, both in terms of the product and everything else. So we haven't come across any infections yet.
Well,
there's so this is our general model of engineering projects, what people do and what we're trying to do to them, I suppose, which can be quite a nice thing to illustrate, I suppose. But we're really looking at the premise that everything is made in a project by a person and their activities. So we're really looking at digital objects, which are outputs of activities, and digital objects will be part of whatever the outcome of the project is. So people are trying to make something, we don't really mind what they're trying to make, we're looking at the things they make through it. And those digital objects, because they're made by the engineers during their activities, have embedded somehow and somewhere within them a huge amount of information about all of the features of the project under which the engineer was working, and hence there is the capability within those digital objects to imply the actual project state and what's happening in quite a broad spectrum within the project. because everything that's made is a result of the project and its state. So we're trying to go a couple of levels of abstraction through from these quite manifest and literal digital objects all the way through to project features and this pattern understanding. And we're doing that through our analysis, something we call signatures, which I'll mention again in a second, but those are patterns with meaning, with a known implication and meaning. So you can say, well, this trace is doing this, and we know that because that trace is communication levels, and we know that this is step change, that means X, or that means Y. So we've got signatures where we know the meaning. We've got indicators where we know a certain graph reflects something, but we don't quite know what the meaning is. And then we've got patterns where we're just trying to find repetitions, sort of things. So just if I use those different words, they do have different meanings. And you can call me out on them if I start using them wrong. But we're trying to take all of this from various different sources of management information, so lots from literature. We were about a year into a 5-year project, 4 years left. So everything's been quite theoretical and literature based at the moment, and we're getting more and more industry input now as we go through. We have to get a bit of a grounding first. I'm sure you've all experienced when you go and talk to a company and ask them what they want. No idea, absolutely no idea. They always want something roughly similar to what they've already got, but works quicker, which very admirable. That will do the job, but only if that's what they actually need. So we've had to get a good grounding first, so we can actually start to parse what the companies say and work out what they do need before they start telling us. And the important thing to point out here is this is a feedback loop. So everything is designed to be as real-time as possible so that we can feed back any analysis that we do straight back into the same process from which it came. So people can monitor themselves if they want to. Managers can monitor what's happening in their projects, which has some slight ethical issues as people work within their projects as well. But so we're trying to provide suitably general information that's not going to get anyone fired if they decide to spend half a day on BBC rather than on CAD programs and that sort of thing. Yeah.
Have you experienced that the digital objects alone are representative of a project?
Yeah.
Okay.
Yeah. It's all through different types of analysis. I've got a few examples later on, but they represent. It depends how you analyze and how you interpret, of course. So depending on what we're doing with it, you can pull different pieces of information out to various different levels of accuracy and validity.
Okay.
But we've had some fairly strong evidence that it's all possible as long as you know what you're trying to look for and you're not trying to go too far too quickly. But you've also just got to work out what level you're describing things on as well. Because if you try to describe things on too abstract a level, as I'll mention in a second, it becomes a bit of a mess and you can't work out exactly what you're saying to what extent within each different area. But if you start couching yourself at the appropriate level, then you can start to say something useful, which then someone who is in the company can interpret at higher levels with more accuracy than we can manage not being in the correct context.
Okay. Yeah. I was just thinking about all the stuff that goes on between people that is not in an email or I was just considering how you could capture something like that, because I think that plays an enormous role. But
that also, there's certain amounts of information loss that are always going to happen. I think in companies that are very face-to-face and pen on paper rather than digital, there's going to be less interest because of that. But the important thing is they still don't have any of the methods or any of the metrics or any of the processes that will allow them to do this sort of monitoring. And so there's a best we can get level with some companies. It tends to be the smaller the company, the less they're dedicated to this digital sort of stuff, because they're in the same office, co-location, that sort of thing does wonders for productivity as well. But partly there's a good argument that if we can provide the means, people will start following the processes that will allow them to have the benefits from the means. And the other thing we've got to just say is, yes, there's going to be information loss. People are going to talk in front of the water cooler rather than send each other an email. Absolutely nothing we can do about that, but what we can do is provide the tools that will let them gather as much information as possible from all of the emails that are sent. Even if they do communicate in front of the water cooler though, if they're using CAD, which the vast majority of engineering companies are, they are still producing digital objects. And there's a huge body of digital objects that are now used and are always produced and are analysable that people don't look at the moment. We get an industry that's quite a hang-up really on emails, because they say, well, people don't use emails all the time. They call each other, they speak to each other, or they use social media, or they use various other different internal tools and Yammer and that sort of thing. So you can't look at emails, and even then, we can't give you the emails because they contain personal information and all this sort of thing. So they become quite a focus of a lot of our meetings. Is we don't want to deal with emails because we don't think they reflect things, and as a result, they start thinking, well, the project's not going to work because we're not going to give you our emails. But emails were one of our different types of digital object, these communications, and there's also all of the files and everything that they actually make as they go through, and those actually provide a much better representation of the progress as things are being done. Your emails, you can say people are working, but you can't say necessarily what parts they're working on and where they're taking them from and how iteration's going and whether people are going through feedback cycles and iteration cycles on different components within designs. You can get hints at, but particularly when you're trying to do it automatically, it's very difficult to look at the text within an email and derive the content and work backwards. So our project, we've got these 5 different areas, levels in it really. Every time we present this, there's an extra level or one level less or something like that. But really we're trying to create the connection between these low-level digital objects, analysis, analogous to sensors. We were saying taking these individual, very small, very low-level measurements of lots and lots of different attributes of digital objects. And we're trying to derive different indicators and signatures of features of projects. And I've got another slide on what features we're talking about in a second. And then providing information about all of these different features such that someone who's in the company, a project manager, engineer, whoever it might be at whatever level, can look at the state of all the different features within a project and use that to make their own judgments on how things are going, what the interventions need to be, if there need to be any interventions, monitor as things go, see how things have gone in the past, see whether there's an effect to any of their interventions, which is something a lot of them are very interested in. Is a lot of the managers will know that something needs to be done and they'll do something, but afterwards they've got no idea whether what they did was the right thing or what the changes were, and they say, well, I've got people to talk more, and so that's the end of it. They don't actually know whether that had the positive effect that they wanted, whether it's essentially placebo in the fact that the manager says anything, gives people the kick that they need in order to do their work, or whether they should have actually been doing something else. And there's a huge number of options, and that's something they're quite interested in, is being able to say, well, I was in this situation, I made this intervention, and this is what changed. Exactly, directly what changed. The next time they're in that situation, do something slightly different, and they can experiment and research as they go through their own projects to see what works in their own situation as they go through. And so this is up at the top of that. So I mentioned before, if you're too abstract, it's useless, essentially. I think I've got an animation in there I don't need. So our original place we were looking was project health. And right from the theoretical side, we looked at all of the different ways that projects can fail, causes of success and causes of failure. So success factors, success criteria, all through management literature and engineering literature. And we distilled out 17, I think that's now 14 different project health factors. So if your project is good in this area, it's more likely to be successful, or it's probably better the other way around. If this area is bad, your project will fail. Or if this area is bad, your project will fail. And then we were going to start trying to do this analysis of digital objects to work out whether we could say what the state of each individual health factor was, which would then be something like our slider on the right, on the top even, or some form of summations or functions of each of these individual things in order to produce this high-level understanding of how healthy your project is, which you could then drill through to say which part or which factor is the one that's contributing the most to the lack of health, should it exist, which we found to be largely useless because they're too abstract to feed information into. And we would look and say, well, project definition, what exactly makes project definition? We don't really know. When you say, well, you need to measure project definition, what do you need to look at in a project? Don't know. Team traits, what's healthy team traits, what's unhealthy team traits? Absolutely no idea. We know what. Well, it's true though, because you can have lots of communication, could be a very healthy thing. Absolutely no communication could be a very healthy thing. A team of one person could be a very healthy thing. A team of 100 could be a very healthy thing. A cross-functional team could be a very healthy team. A entirely engineering stress analysis team could be a very healthy thing. And we know that all of those things go into team traits, and they're all a factor, but with absolutely no idea which one's useful and which one's not. And it's all down to sort of context specificity and just a lack of precision, I think, in those sorts of terms, which is something that I think flows through quite a lot of the higher level management literature. Is quite a high level of generalism that doesn't break down to what you'd actually expect to see in a project. And so we were aiming at these sorts of things from the low levels to start with, and found it impossible to reach the middle ground between our analysis and what we can say about projects. And we just can't say what's healthy and what's not healthy. We need to go another level and just start saying what is, and leave that then for someone else to say whether that's a good thing or a bad thing. And so we've found this is nigh on impossible to read, but I do have better pictures of it that don't quite do this when you put them in a PowerPoint presentation. But each of these bubbles is a different feature of a project, and that's really difficult to define, because when you look for what the definition of a feature is, it says an aspect. When you look for the definition of an aspect, it's a feature. But it's just some part of a project that would fit under a category to which you can ascribe certain information. So we've got ones related to people. So up here, there's things like motivation, sentiment, cohesion of teams, and that sort of thing. We've got ones related to process. So over here, we've got things like the delay in processes, bottlenecks. Really can't read this now, can we? We've got process structures, process capabilities, company hierarchy, communication levels, activity levels, types of communication between internal and external stakeholders, compliance, IP, product structures, product dependencies, process complexities, all of these sorts of things. And there's, I think, 74 around here, and all of these we've pulled really from literature at the moment. So the way we went about this is, I think I found 15 references for every single thing that I could, where the reference specifically said that this individual thing is important for project performance. So each one of these things is important for project performance, and we've got 500 references to prove it. So that means we can, companies will believe us, which is quite nice. But what we've done with this is take it to a couple of companies, and one was particularly interesting. We showed it to a manager, higher middle manager, got him to talk around it and say, out of all of these things, which ones would you want information for? And out of all of these things, which ones wouldn't you really want information for? What do you think is important and what do you think is not important? Hoping to get a bit of direction, because 74 odd different things, that's a lot of analysis that we can start working towards. And he had the very unhelpful, very interesting, but very unhelpful view of, yes, there are certain ones that he's interested in, but his co-worker who's on exactly the same level would be interested in all of the other ones. And there's absolutely nothing that he would say, cut that, or don't look at that, or I wouldn't worry about that yet. And having spoken to a few different people. You go?
I think that's probably a significant challenge, that people have their own, view of how projects work, and what constitutes a good project, and what's a bad sign and what's a good sign. But do you have any evidence from literature, or have you considered exploratory studies, for example, just cases looking at good projects and bad projects, and see which traits do you find in good and bad projects?
Yeah, so we're doing that from this sort of level at the moment. I'd say the stuff we've looked at and that we've found all tends to be at the slightly more abstract and not as useful level. Yeah. So when they say why things didn't go well or why things did go well, they would say poor understanding of internal company technology, or external stakeholders were not engaged to a significant point. In fact, they think, okay, that's probably very, very true. But like we were saying before, is that a symptom or is that a cause? That could be because of a multitude of other things underneath. And even then, it doesn't actually say what's going on in the project, and it's not something you can pull up from low-level monitoring. So that's the problem we've sort of been having with the middle ground, is that lots of the literature comes from the top down to about here, and lots of the stuff comes from the bottom down up to about there. And there's just this middle bit where we start need to say, this is the effect on the project of what these people are doing, and this is the state of the project that reflects this certain thing that's good or bad. somewhere in the middle.
But you don't have access to the low-level data on those kinds of projects, so you could
Not-
connect signatures, try to.
We don't
see
on the
what's
ones that
happening.
are in literature in publication at the moment, but it's what we're gathering.
Okay.
So one of our companies, we've now proven ourselves apparently with their small data sets that they gave us to start with, and they're going to send us through a few more of projects that went spectacularly wrong. One that was meant to be 3 months and took them 3 years, and things like this. So hopefully we'll be able to start pulling this out. And it'll be quite interesting to get people who do it for a living to do the very high level analysis, and we'll work through from the bottom and do the middle ground, and we can start seeing where we meet for the rest of it. I think that would be quite an interesting thing. And try to get a full project spectrum understanding rather than just high level or just low level as we go through. And so this is down at the bottom of those 5 blue things I had before. So you know what digital objects are. What we're doing with them is we take the various different attributes of digital objects. Attributes we put in sort of like a metadata level for one group, so creation dates, who the author was, modification dates, and that sort of thing. We've also got a content level, where it's what the actual content is, and there's various analysis we can do on that. We've got a context level, which ties that more to which teams it came from, the situation in which it was developed, and that also ties to things like provenance and importance of certain things over certain other ones, and whether that needs some form of weighting. We've really been looking at just the basic ones of those at the moment, so things metadata and content. And what we do is we map these attributes, usually in traces with time, but we've got a few other different analyses that I'll show in a little bit, and then try to take some form of pattern analysis that comes out of these different attributes and say what's going on in the project based on that. And that turns from our indicators into our signatures, and then we look in our signatures and say, well, what's the actual content of this indicator? Is there something that we don't expect? Are there step changes when there should be? Are there no step changes when there should be? Do we get things going up in the same rates? Do we get things splitting off, things staying together? And then try to attach some project-based implication or meaning to each of those individual patterns that someone else can then interpret in their own individual project. And so that's really our approach all the way through. So we've got lots of questions that attach to that at the moment. We're only a year in, but we're making some decent headway. We've got plenty of examples coming up soon. We're asking these sorts of questions at the moment, but it's really all the way down from the low level. How do you gather this data? How do you manipulate this data? Because it varies in form hugely just by nature. And then you go to a different company and find that they use CATIA rather than SolidWorks. And as a result, you need to remake every tool you've developed in order to deal with the different software structures and coding structures of those. Or some of our companies use their own internal communication systems rather than email, which is absolutely fine, but it then means, again, you've got to rewrite all of your tools, which means we need to find some form of common form for these things and some form of database or facet and classification form that we can then perform analysis on. And all of these questions all the way up to what actually is the most useful, actionable information for different people in different companies. And that links through to what are the basic, if you look at those project features, certain ones of those features would give you a far better understanding of, for example, the standard iron triangle in project management and time, cost, quality. So you could find which features tell us something about whether a project's on time or going to be late, which features tell us more about cost, whether a project's going to be on cost, on budget, or just how far over budget it's going to be. You can also separate things out by styles, management styles. So the example I mentioned before, but there's various different classifications of management styles, and so you can say, well, people who are nurturers, you would give them these features or data on these features to match their personal style, or perhaps you would give them data on these other features because that's going to change them into someone who's slightly more balanced or productive, back to manipulation. Or you might do some other subcategorization of these different features according to some other type of understanding in order to work out what actionable information we can give to people. And so I'll pause there, say if anyone has any questions or anything, but then I've got a whole bunch of examples that might illustrate things a little bit better. Or should I just roll through the examples?
Yeah, we'll have about till about 10:30, so let's just...
Yep, just keep going.
Well, it depends. There's probably questions.
No, I would actually like to see some of the examples.
Yeah,
actually.
yeah.
So that'd
Yeah.
be nice.
So this one is big data set. We have 16,000 emails on one project spread over 4 years of I think I'm allowed to say marine engineering company in Britain, and no more than that. So this wasn't automatic, unfortunately. This was manually coded, and they coded lots and lots and lots of emails according to a fairly developed coding scheme looking at quite a few different things. But this one is showing the type of email according to the type of activity that was completed, and they mapped different points at which different things were going up and different things were going down, and the relationships between these different types going up and going down, and looked at, if you look up here, if you have an information type of email increasing in quantity or proportion and the other one's going down, what does that then mean for the project state? And if you've got a different pattern of these, what does that mean for the project state? Like, for example, does a certain pattern of information up, management down, problem solving down mean that you need more managerial input in order to increase the problem solving work that should be going on given the certain stage of the project, and that sort of thing? And there's 8 different combinations of these 3 arrows that you can have. They made a hypothesis for each of them of what it actually meant in terms of the project, found the stage of the project that it would reflect, then took it back to the engineers and the guys in the companies, and they said, yes, that's what was happening in our project, that's what our project needed. Sometimes it's what they did, sometimes it's not what they had done in order to fix things. But these recommendations, based on the certain types of different emails that were going through, did accurately reflect the individual state of the project at that point in time. And if they'd been able to automatically produce this sort of information, could have been something that would have been actionable for the managers. Based on this trend that we've got at the moment, more managerial input is needed in this specific part of the project. And that's something they would have been able to work out themselves based on the trends and the arrows that they see appearing. Also looking at the same data set, this one is entirely automatic, quite a lot more basic, but even just looking at contributing people, and there's a bit more analysis than just contributing people behind this one, but it's a good summary. There's certain patterns that we found within, so certain points of inflection directly at stage boundaries, which is something that seems very sensible to me when you have a team pass over, but it doesn't mean that we can automatically say, firstly, which department, which stage of the process. You can measure progression rates. You can start to measure progression rates. You can start to set normal progression rates for individual types of projects, and when you can know what normal progression rates are, you can start to say when things aren't what they should be, and hence whether people should be looking at individual things. So even from what's actually quite a basic analysis of people contributing or not contributing to the project, and whether there's new people being brought in or not being brought in, you can determine quite a lot about the dynamics and structure and hierarchy and what's going on in the project proper and the activity levels. This one is difficult to explain, but it's essentially each of these bubbles is an individual topic, and those topics are derived through a combination of clustering and n-gram analysis on the subject lines of all of the emails in this big corpus, and that works quite well actually. So he can, this is a guy called Simon in Bath, worked out exactly what people were talking about, and you can start to map, as you look at this through time, people starting to talk about the same thing, and cohesion and shared understanding appearing in certain topics, and people splitting off, and people specializing in certain things and developing their own language, and certain types of content appearing at certain stages, so what people are working on, what people aren't working on, and that sort of thing. But the actual analysis part of this comes from something in computer science that I can't remember the name of at all, but depending on where, according to this analysis, the little bubble is, so where in those boxes it is, it can either be classed as something that's, they call emerging or declining, which is just background noise in topics, basic and transversal, which shows the growth of certain areas in the project into something that's actually quite important to the company, or starts to describe the main bulk of work, core and developed, which is the real meat of what's going on in the company at that point in time, or developed and isolated, which is best viewed as sort of individual specialisms of certain teams. And so what you can do from this is, taking the data from individual people and across companies, you can automatically determine the experience and expertise of different people. You can do progression through depending on what they're talking about. You can start to detect when people are talking about things that they perhaps shouldn't be, which might be an early warning indicator, or it might show some iteration. Or one of the examples we had in this was they started talking about contracts at the wrong point. And that's a big flag, because they shouldn't be talking about contracts when they're coming to the end of a project, and something quite dramatic had gone wrong with contracts in this one. But if they'd had this analysis, and if they'd been monitoring, they would have seen contracts quite a few weeks before everything really kicked off, appearing in the bottom left, and then slowly moving over to the bottom right, and then shooting up and growing to this sort of size in the top right, and that's when everything went wrong. And all that needs is a person looking at it every now and then saying, what are the bubbles talking about? Contracts. That shouldn't be here at all. And then chasing that, and that probably couldn't have been prevented. I think it was someone in the legal department. But they would have at least known what was coming and could have mitigated it. It wouldn't have been something that would have been quite as big an issue as it was. So it's that sort of analysis. Yeah?
Technical question, is that some sort of keyword network analysis? Because the axes are centrality and density.
Yeah. Okay. Yeah, it is. So we developed a network that defines all of the topics, and so they're quite malleable, really, the topics as they go, and certain things will become connected to other things and split. So there's quite a difficulty in here in defining what the boundaries of an individual topic are. And just when things are growing together, when you say that's become one topic, whether it's still a few topics that are merging. So there's quite a bit of complexity inside the analysis techniques in this one. But hopefully with time it's something that will improve, firstly, and secondly, it's more a means of providing people in the companies with knowledge about what's being talked about that they can interpret themselves. So we don't need to say that the frame people and the engine people are merging like this or like this until it's become a defined bubble, and we can say you've now defined bubble, well done. What we actually do is say you've got these groups and these groups that are coming together, and it's the people in the company who'll start to say that should this be close together, or should these actually be a bit further apart, or that sort of thing. So we're trying to do as little of the interpretation ourselves as possible. We're just trying to do the analysis and hopefully present it in a way that doesn't need a 10-minute explanation of what the graph actually is. But all of that's going to come with time, I think.